This video addresses North Carolina Math Standard 3 and F3, composing and decomposing fractions into equivalent fractions using related fractions halves, fourths, and eighths, thirds, and sixths. There is more to the standard, but in this video we will only be covering the second bullet, explaining that a fraction with the same numerator and denominator equals 1 whole. 3 and F3 calls for students to explain that fractions with the same numerator and denominator equal 1 whole. Students must use a model to gain conceptual understanding of this standard. In third grade, students are expected to use area and length models to compose and decompose fractions into equivalent fractions. Length models can be used with students to help them develop the concept that a different number of parts can be created to form a whole. In third grade, models are used to help students understand equivalent fractions. We can use length models to represent the whole and parts of a whole. This length model represents 1 whole. If I divide this length model in half, I get 1, 2 halves, and I can see by looking at these models that 1 2 halves is equivalent to 1 whole. Okay, so then again I have the whole length model, and I'm going to see if I divide it into 4 parts, how many parts are needed to make a whole. 1, 2, 3, 4. So by using the length models, we can see that 4 fourths are equivalent to 1 whole. Now let's see how many eighths make a whole. 1, 2, 3, 4, 5, 6, 7, 8. So by using this model, we can see that 8 eighths equals 1 whole. You can also use number lines to help students conceptualize that a specific number of parts equals a whole. Okay. Draw this number line. And I can label my number line 1/3, 2/3, 3/3. So now we can see that it takes 3/3 to equal 1 whole. We can do the same with 6 and divide it into parts, and we see that 1/6, 2/6, 3/6, 4/6, 5/6, 6/6 equals 1 whole. As shown in the video, Standard 3 and F3 require students to explain that fractions with the same numerator and denominator are equal to 1 whole. Students can explain their thinking by using length models. In second grade, students were required to partition shapes into halves, thirds, and fourths, and were expected to recognize that a whole is the sum of its parts. Students were also required to use different area models to partition shapes into equal parts, such as circles, rectangles, and squares. Third grade is an extension of what was learned in second. In third grade, students are using different models to strengthen their conceptual understanding of fractions. Students were also expected to divide the same shape into equal parts in a different way. In fourth grade, students are asked to explain why a fraction is equivalent to another fraction by using area and length fraction models, emphasizing how the number and size of the parts differ even though the fractions themselves are the same size. Students expand the range of denominators to include 2, 3, 4, 5, 6, 8, 10, 12, and 100. This concludes the second part of Standard NF3, representing equivalent fractions with area and length models. Please continue to watch the third video, which you will learn more about representing equivalent fractions in grade 3.